All right, Katniss, let's do this. So it says that if Katniss Everdeen fires a 30-gram arrow at 50 meters per second on the frictionless surface, calculate her resulting velocity across the ice. So we've got Katniss, we have arrow, then we have Katniss after, and we have the arrow after. Mass of Katniss, 60. Velocity of Katniss to start is going to be a 0 because she's not moving to start, which means that the arrow, 0.03, is also at 0. Thanks. And then Katniss after, her mass is going to be, she will have removed 0.03 kilograms from herself because she's losing that arrow. So she's going to drop down to 59.97. The arrow's mass is going to be at 0.03. Her velocity is what we're looking for. The velocity of the arrow is going at 50 meters per second. So if we look at this, remember that our total momentum before is going to be equal to our total momentum after. So Katniss plus the arrow is going to be equal to Katniss after plus the arrow. And we've got a lovely little setup here because everything before is going to be a 0. So we now put that into 59.97x plus 0.03 times 50, which is 1.5. I'm going to subtract 1.5 from both sides. And that gives me negative 1.5 is equal to 59.97x. Divide both sides by 59.97. And we're going to get a value for her velocity at negative 1.5 divided by 59.97. And that gives us negative 0.025 meters per second. Okay, so moving on to the next portion of this question. Part 2 reads that she then immediately, as in she's still moving, and so are her arrows, a second arrow, but at an angle of 30 degrees to the horizontal. Wah, wah. Find her new final speed. So we've got Katniss and the arrow together at the start. So I'm just going to combine these here because it's another explosion problem. So Katniss and arrow are working together at this point in time. So this is the reverse of a total inelastic collision because it's an explosion problem. She is going to be relieving herself of some portion of this mass in just a little bit. So her starting mass is going to be 59.97. Her velocity is going to be negative 0.025 meters per second. And we're going to set that equal to herself after and her arrow after. So her mass after, she's going to be now 59.94. The arrow's mass is 0.03 kilograms. The velocity we want to know for Katniss's side, the velocity here is not going to be 50 meters per second because it's 50 meters. This is the total value that's getting launched off here. So of course, if we're at an angle of 30 degrees, we got to bust it up. So in this case, we're looking at an adjacent over a hypotenuse. So this here is going to be 50 times the cosine of 30. So that gives us, let's just do this. 59.97 times 0.025 is equal to 1.49925. And we're going to set that equal to 59.94x plus 0.03 times, let's do 50 cosine of 30 first, make sure it comes in the calculator the right way. 50 cosine of 30 times 0.03 gives us 1.299. So I'm going to take this equation here and I'm going to move it over so that we can solve it in kind of a cleaner space. So we have 1.49925 is equal to 59.94x plus 1.299. Subtract 1.299 from both sides. So, This is a negative. Whoops, I was like, wait a minute. Okay, sorry. So this is going to be a negative, because her initial velocity is negative, and I originally listed it as a positive. See, I knew something was wrong because this was going to give me a number. If I just subtracted this as a positive value, I was going to get a positive number, and that would have put Katniss moving back in the opposite direction. I knew I needed a negative number over here. So that's why I stopped what I was doing, went back and looked, and said, okay, why am I still getting a positive number over on this side? Oh, because I forgot to bring my negative down. So we've got a negative 1.49925 minus 1.299. There we go. That gives us a negative 2.79825 is equal to 59.94x. Divide both sides by 59.94. 59.94 divided by 59.94. And we get the velocity of Katniss afterwards is going to be equal to negative 0.047 meters per second. Bam. I'm going to upload part 3 of the video in just a second.